To get the most out of this video, there's one thing I need you to do. Make sure to pause and attempt each question on your own first. If you don't do this, my explanations will not be nearly as helpful. Okay, let's get started. We're going to start with 4 easy questions, 2 English and 2 math. And our first question here is obviously an English question. Based on the text, how would Singh and Roy most likely respond to the research in text 1? So we've got cross-text connections. As you may have noticed, I like to start with the question so I know what it is I'm looking for. And we know that we're looking for text 2's most likely response to the research in text 1. And there's 2 ways we can go about this. We could either figure out what that research is and then get some context from text 2, or the way that I'm going to do it right now is starting with text 2 and then going to that research. Governments in democratic countries function better when more people vote. However, forcing people to vote may have negative consequences. Shane P. Singh and Jason Roy studied what happens when a country requires its citizens to vote. They found that when people feel forced to vote, they tend to spend less time looking for information about their choices when voting. As a result, votes from these voters may not reflect their actual preferences. So I'm just going to give myself a little main idea here. I don't know why my text is huge. And my main idea is going to be basically voting good, but forced voting bad. Now, research in text 1. Let's see. Normally I would try to pinpoint where the research is and maybe skip some of the text, but this chunk of text is so small, I'm just going to go ahead and read the whole thing. Public policy researcher Anthony Fowler studied the history of elections in Australia, a country that requires citizens to vote. Okay, so we see the connection there. Fowler argues that requiring citizens to vote leads to a significant increase in voters who would otherwise not have the time or motivation to vote. Thus, election results in countries that require citizens to vote better reflect the preferences of the country as a whole. Okay, so I'm already seeing an issue here. Voting good but forced voting bad, where text 1 seems to say forced voting good. And I wouldn't necessarily write this down. This is just to give you an idea of what I'm thinking about. So how would text 2 respond to that? I'm guessing that they would emphasize that these votes may not actually reflect their preferences, specifically because they spend less time researching the candidates. And I'll go through and I'll start eliminating. Only countries of a certain population should implement mandatory voting. There was no mention of population size in either of these texts, from what I remember. So that's out. People who are forced to vote are likely to become politically engaged in other ways, such as volunteering or running for office. That's also not what I said. Requiring people to vote does not necessarily lead to election outcomes that better represent the preferences of the country as a whole. Yes, not as specific as I would like, but yes. Countries that require voting must also make the process of voting easier. No. All right, so it's definitely going to be C. All right, this next one, we've got a function-based question. Always looking at the function of the underlined sentence. I would recommend reading through the whole thing, but really honing in on that underlined portion. So historians Tia Miles and Roy E. Finkenbein both have documented the assistance indigenous peoples gave to black freedom seekers leaving the South before the U.S. Civil War. Much of the historical evidence of this, historical evidence of indigenous peoples helping black freedom seekers comes from indigenous oral traditions. So that would be stories just told out loud but not written down, and from autobiographies written by the freedom seekers. One such narrative, so we know one such narrative is referring to one of these autobiographies, is Jermaine Logan's autobiography, which tells about how these villagers offered him food, lodging, and directions during his 1835 journey from Tennessee to Canada. So my anticipation here is going to be that this is acting as an example of one of those autobiographies that told about how indigenous peoples helped black freedom seekers. A, it provides an example of an autobiography that describes help given by an indigenous people to black freedom seeker. That is exactly what I said, so I'm going to keep that. It shows why Logan decided to write in great detail. It does not. It argues that autobiographies were particularly important sources of information. It does not. It suggests that most historians believe these villagers were more successful. Nope, it's A. And the reason that was so easy is that I had an anticipation or a prediction of what the answer should be beforehand. Always have that ready in the English section for these reading-based questions. So our first math question here is a little bit of a word problem. I do like to focus on the main part of the question here as well, just so I know what it is that it's asking. In this case, because all the answers are equations, I already know that it wants to know what does the equation look like for this scenario. So I'll actually just kind of go with that. And based on the way these answers look, we're definitely dealing with y equals mx plus b, which is a linear equation or a linear function. You can see we have h is y, s is acting as x, and then the whole number is going to be our b. An easy way to approach these is to think about what does slope represent and what does y-intercept represent. So your slope is m, and in the context of a word problem, slope is going to be a constant rate of change. And b is our y-intercept, and that is going to be a starting point or initial cost. So let's look for both of these things. Do we see a starting point? Do we see a constant rate of change? The front of a roller coaster car is at the bottom of a hill and is 15 feet above the ground. Seems like we've got a starting point. 15 feet above the ground is where it starts. So based off of that, we could just go with A and get our correct answer. But if we also want to just double check that our constant rate should be 8, if the front of the roller coaster car rises at a constant rate, it actually even has that phrase constant rate of 8 feet per second. Boom. So we're totally good there. It's A. Our next easy math question is a system of equations, specifically a system of linear equations, and it's asking for the solution. Well, this one's easy enough. Solution means where do the lines touch? I see 1 point right here, so I'm going to count my x's, 1, 2, and then my y, 1, 2, 3. The answer is 2, 3. Moving on to central ideas and details with our first medium question. Based on the text, what can be concluded about the diminishing popularity of the portrait miniature in the 19th century? So basically, why diminishing popularity of the portrait miniature is what we're going to try to focus on. Now, I'll read the text out loud, but if I were taking an exam and I came across this question, I'd be reading this in my head, but kind of skimming through and looking specifically for a mention of the diminishing popularity of the portrait miniature. A common assumption among art historians is that the invention of photography in the mid-19th century displaced the painted portrait in the public consciousness. The diminishing popularity of the portrait miniature, so this is where I'd be focusing, which coincided with the rise of photography, seems to support this claim. However, photography's impact on the portrait miniature may be overstated. So far, we would say not photography. Photography is not the main, or at least not the only cause of portrait miniatures diminishing popularity. Although records from art exhibitions in the Netherlands from 1820 to 1892 show a decrease in the number of both full-size and miniature portraits submitted, this trend was established before the invention of photography. Yeah, so basically, like I said, I think this sentence is really what we should be using. Photography's impact may be overstated, so it's not the only cause of the portrait miniature losing popularity. Let's eliminate. Factors other than the rise of photography may be directly responsible for the portrait miniature's decline. So that does go with what we were saying. I'll keep that one. Although portrait miniatures become became less common than photographs, they were widely regarded as having more aesthetic merit. That has nothing to do with what I said. The popularity of the portrait miniature likely persisted for longer than art historians have assumed. That also has nothing to do with what I said. As demand for portrait miniatures decreased, portrait artists likely shifted their creative focus to photography. It also does not mention that, nor was that my anticipation. So A is certainly our answer. Our question is which most logically completes the text. That means we're dealing with an inference question. And for inference questions, I do recommend you at the very least read quickly through the entire passage so you have full context and can come up with a prediction or anticipation of how the text might end. In her 2021 article, Throwaway History Towards a Historiography of Ephemera, scholar Anne Garner discusses John Johnson, a devoted collector of items intended to be discarded, including bus tickets and campaign pamphlets. Johnson recognizes that institutes considered his expansive collection of ephemera to be worthless. Indeed, it wasn't until 1968, after Johnson's death, that Oxford University's Bodleian Library acquired the collection, having grasped the item's potential value to historians and other researchers. Hence means therefore, or according to what was just stated, the example of Johnson serves to blank. So I'm going to guess that it'll be something like the example shows that value really changes depending on the time period or by, perspective. So the example serves to demonstrate the difficulties faced by contemporary historians in conducting research without access to ephemera. Nope, that is not what I was saying. Represent the challenge of incorporating examples of ephemera into collections of libraries. No. Lend support to arguments by historians and other researchers who continue to assert that ephemera holds no value. No, because we found that it did hold value in the end. All right, it better be D because I don't like those other answers. Illustrate both the relatively low scholarly regard in which ephemera was once held and the later recognition of ephemera's possible utility. I don't love that answer, but I guess it works. It does go along with the part where I said, sometimes things will be more valuable depending on the time. So that later recognition fits with it. And, it definitely does illustrate both of those things. So D is going to work. All right, so we've got a word problem here. And word problems, you don't necessarily know what you're dealing with until you read through. Some things that I'm noticing. I see different types of packages. We have 100-pound packages versus 120-pound packages. So those are types of packages, but then we also have a total number of pounds. Total number of pounds. And we're counting packages too, right? So we're counting packages, we're counting pounds, there's different types. The reason I'm pointing all this out is when you see two different types of the same thing with different values, you're dealing with a system of equations. So what I want to do first is decide what's X, what's Y. So I'm going to say 100-pound packages are X, and I'm going to say 120-pound packages are Y. So let's write our first equation here. We know that X plus Y, all of our packages together, need to equal at least 10. So we could say that they are greater than or equal to 10. That way, they're not going to go below 10, right? And then our other equation needs to account for the pounds, because remember, X and Y were the number of packages. So for pounds, we just need to include the pounds affiliated. So since each 100-pound package is 100 pounds, we would say 100X plus 120Y is going to be at most 1,100 pounds. So this needs to be less than or equal to 1,100. First, let's talk about what we're trying to do. We're trying to maximize the number of packages in order to do that, we want to have as many pounds as possible. So I'm going to change our bottom equation to equal to, because to maximize, we would want to be as high as possible with equal to 1100, right? All right, so we know by setting this equal to 1100, we are going to have as many pounds as possible. Now, what can we do with this x plus y is greater than or equal to 10? Well, in order to make y 120 as big as possible, since we're trying to maximize it, we want to minimize x. Let me show you what I mean. If we rewrote this, if we moved the y over and we had, subtract y, let me change colors actually. So we subtract y and change this to x is greater than or equal to 10 minus y. So we want to minimize x, right? We want to minimize x. That means we should change this to equals, because we don't want x to be any bigger than this answer. We want x to be as small as possible. So x equals 10 minus y. All right, we've minimized x, aka maximized y. Just to make things simple, since this, we know that setting this equal actually ends up maximizing y. So I'll change this to equals, because this is literally the same equation, just written a different way. And then elimination is the route I would go if you want to go ahead and write things out. At this point, you could also just plug this into Desmos. We usually cover the Desmos strategy on this channel, so just this once, I'm going to show you the elimination strategy. Basically, we want to match things up and get rid of the x's so that we answer for the y's. So in order to eliminate the x's, I'm going to multiply my top equation by negative 100. Why am I doing that? Because when I add my two equations together, negative 100x plus 100x is going to eliminate itself, right? That's why it's called elimination. So we have negative 100x. Here, let me actually move some stuff around real quick. Distribute that negative 100. Negative 100x minus 100y equals negative 1000. Then we add our two equations together. Like I said, negative 100x plus 100x, that cancels out. That's exactly what we wanted. We have negative 100y and 120y, so we have 20y left over. 1100 minus 1000 is 100. Divide by 20, and y equals 5. All right, we've got another word problem. And I want to start with the main question. It says, according to the model, what would be the head width of a worker bumblebee that has a body weight of 0.5 grams? So we know we're going to plug in 0.5 grams as body weight and then plug that into some sort of model or equation. So let's try and make an equation. According to a model, a head width in millimeters of a worker bee can be estimated by adding. All right, so let's start this. The head width we're going to say is h. H can be estimated, so we'll say that's equals, can be estimated, is adding 0.6, so that'd be plus 0.6. And I'm putting it over here because it seems like that might be our y-intercept, and this might be linear, by adding 0.6 to 4 times the body weight. So 4 times the body weight, we'll call that b for body. Okay, in grams. So as you can see, we do indeed have a linear equation. Y equals mx plus b. In this case, h is standing in for y, b is standing in for x, and our y-intercept is 0.6. Now, we already know that we just want to plug in 0.5 into body weight. That's what we determined in the very beginning. 4 times 0.5 plus 0.6. And you could plug that into your calculator, or, 4 times 0.5 is half of 4. That's 2 plus 0.6. Our answer should be 2.6. Our first hard question is going to be words in context. We know that because we have to fill in the text with the most logical, precise word or phrase. For these, I do like to read the whole thing for context and come up with a prediction. That said, sometimes it's hard to come up with a prediction. And if you do run into that issue, go ahead and just start eliminating answers. So we've got economist Marco Castillo and colleagues showed that nuisance costs, the time and effort people must spend to make donations, reduce charitable givings. Charities can mitigate this effect by compensating donors for nuisance costs, but those costs, though variable, are largely blank donation size. So charities that compensate donors will likely favor attracting a few large donors. So because it says so, this is what we want to look at for evidence of what should be in the blank here. It's likely that charities will compensate donors will favor attracting a few large donors over many small donors. Why would you want fewer donations? Assuming that we get the same amount of money, the only reason you would want fewer donations is because the compensation for nuisance costs, whatever you're giving a donor for nuisance costs, is the same regardless of if they give you a large donation or a small donation. So those costs are largely blank donation size. My prediction will be not affiliated with, not associated with, not tied to, not connected to donation size, something like that. All right, we have supplemental to. So supplemental to, a supplement is something that you add on, right? If you think about supplements for your diet, if you take like an iron supplement, that is additional iron that you're having other than the iron from your food. I said it's going to be unrelated to donation side, so that doesn't work. And let me actually write down my prediction here just so neither of us forget. So unrelated to, or not, tied to, something like that. Predictive of. So if it predicts it, then it's very much related to it and it is tied to it. So that's the opposite of what I want. Independent of. If you're independent of something, you are not tied to it. You are not relying on it. So that works. I'm going to keep that one. Subsumed in. So here we can look at the prefix sub and think about consume. So if something gets consumed, it's eaten, it's taken in. Subsumed, we could maybe imagine it below. And indeed, subsumed is going to be like contained within something as you could think of it like a smaller category. So for example, cats, dogs, and iguanas are all subsumed under the classification of animal, right? Forks and knives are subsumed under the classification of utensils. Again, it's not what we're looking for, and C is definitely going to be our answer. Our last English question is going to be some good old form, structure, and sense. I know this because it is conventions of standard English, but we don't have punctuation. So by default, form, structure, and sense. Now, of course, there are different things that can be within form, structure, and sense. In particular, it looks like we are dealing with verbs. And what is my favorite thing to do with verbs? Try the odd verb out trick. So we're not even going to look at the text. We're just going to look for an odd verb out first, and then we'll double check to make sure that we're not crazy. Hasn't been. And in case you're not aware of this trick, basically we want to match up each answer with, he or she, or with they. So I'm going to just use she here. So we'll say she hasn't been. That would be correct for hasn't been. She wasn't. She isn't. But we can't say she aren't, right? We would say they aren't. So pretty sure my answer is D. I'm going to circle it. Let me show you the magic though. Let's just double check. The artistic talents, and we do want to focus on the main noun as our subject. So the artistic is describing talents of Barbara Chase Rebound. That of prepositional phrase is also describing talents. Our main noun, our main subject is talents. All of this stuff in between commas we can get rid of because that means it is non-essential information. And then we get talents aren't. Talents are not. Talents are plural. It lines up with they. So the odd verb trick certainly worked in this case. Our first hard math question, we have some constants, and it's asking the value of not A or B, but actually AB. Technically, this is going to fall under equivalent expressions because you have these two expressions that are equal to each other. I would kind of categorize it as a constants question, a constants matching question is what I would call it, because the strategy I'm going to use is a matching strategy. And let me show you what that looks like. So one way to go about this would be, what is A? Find that out. And then what is B? Find that out. And then multiply those together. But it would be a lot easier to just find out what AB is. And what we can do is we can get rid of everything in the equations that are not attached to AB. I'll show you what I mean. So where is AB going to show up? When we multiply AX by BX, we're going to get AB, right? Is there any other place where AB is going to show up? No, A and B will never be multiplied other than that part of foiling this out. So I'm actually only going to FOIL that out for now. AX times negative BX would be negative ABX squared. So that's our anchor. Now, because AB is attached to x squared, we want to pull out everything else that is attached to x squared, because by definition, all of the terms that are at the same degree, whether it be x to the third, x squared, just x, or no x's, just a constant, they all have to be equal to each other. So I'm just going to extract things that are attached to x squared. So on the left side, is there any other place where I'm going to get x squared? Yes, there is. When I multiply 3 by 5x squared, I'm going to get 15x squared, right? So I'm going to add that down here. 15x squared minus abx squared. And then on the right side, I'm going to do the same thing. I'm only going to worry about x squared. So we're getting rid of this, we're getting rid of this, and then we just have negative 9x squared, right? So from here, let's just isolate AB. First thing I'm going to do to really simplify this is just to get rid of x squared, because if we divide the whole thing by x squared, then all of those go away. Now I'm going to subtract 15 from both sides to get negative AB by itself. So then we end up with negative AB equals, what's negative 9 minus 15? Negative 24. And of course, if negative B is negative 24, then AB is 24. Our answer is C. All right, last question here. We are dealing with probability, it looks like. And we do have a lot down here. So just to make sure we're aiming at the right thing, let's look at the final question here. If a contestant is selected at random, what's the probability that a selected contestant received a score of 5? Okay, so I'm going to immediately start honing in on this. A score of 5 on day 2 or day 3. So let's find that first. A score of 5 would be 5 out of 5. So we're looking at this column and it says day 2 or day 3. So basically, what's the probability of these? And a little hack for you, it says, what is the probability that the contestant received a score of 5 on day 2 or on day 3? The importance is, or means plus. Or means you add the probabilities. Add probabilities. It's important to note this because sometimes instead of the word or, you're going to see and. Or is saying either of these things could happen, and is saying both of these things have to happen. And with and, you would multiply your probabilities. So 5 out of 5 on day 2 or day 3, given that the contestant received a score of 5 on one of the 3 days. So that's important. Basically, it's saying the contestant only received a score of 5 out of 5 on one of the 3 days. If the contestant could have gotten a 5 out of 5 on multiple days, then we would have to account for not just day 2 and day 3, but also the combination of what about the times that the contestant scored both. So that makes things simple. Anyway, we know that our target is 2 plus 3 because of the word or. So our target is 2 plus 3, which is 5. And your target should be your numerator. With probability, here's another tip. You're going to have target divided by your total. And your total is going to be the total possible value in whatever category you're looking at. So in this case, because we're only looking at scoring a 5 out of 5, our total should only be the total for that column, 5 out of 5. And it actually gave us the total 7. So our denominator is 7, and our answer is 5 out of 7. I hope you're feeling more confident about your upcoming exam after that practice, but you do want to make sure that you don't get tricked by any of the questions on the SAT. To avoid that, go ahead and check out these videos over here. They're going to cover common tricks in both the math and English sections of the SAT.